Smartass TV, the educational channel for smartasses.
Imagine, a stadium-sized asteroid is going to hit Earth in 2 weeks. Even at this moderate size, a fireball brighter than the sun tears through the atmosphere at 60 times the speed of sound, and the destructive power of 4,000 Hiroshima bombs flattens cities, killing millions. This isn't science fiction. Many killer asteroids were only spotted at the last moment. In 2019, asteroid OK, as big as a 30-story building, was discovered just 1 day before it grazed Earth closer than some of our satellites. Last year, the even larger asteroid MK was spotted 13 days before it passed us closer than the Moon. If they'd have hit Earth, they would have unleashed the destructive power of 3,000 and 9,000 Hiroshima bombs. Stunningly enough, humanity doesn't really have a plan for this. Scientists have devised all kinds of tricks to push dangerous asteroids away, painting it so sunlight will deflect it, landing thrusters to steer it, scorching it with lasers, or even crashing spacecraft into it. But they all have a big problem. They're the equivalent of trying to deflect a cargo ship by throwing a bag of potatoes at it. They do move the asteroid, but only by a tiny bit. With these methods, you need to act years or even decades in advance to make an asteroid miss the Earth. But very recently, scientists have developed a new, spectacular way to destroy killer asteroids that we could implement with today's technology. Let's see how this works with our 100-meter asteroid heading for Earth. The secret weakness of asteroids. For a long time, people imagined asteroids as being gigantic stones made of rock and metal. But it turns out most of them aren't like that. They're more like bags of loosely packed gravel, heaps of pebbles, precious minerals and dust barely held together, which means that instead of just nudging them, we can do something better: pulverize them. And the obvious choice is, of course, a nuke. So let's go. We load up a nuclear warhead, launch, aim at our deadly asteroid and… oh, the asteroid destroyed the nuke. Asteroids can approach Earth at 70,000 kilometers an hour, enough to cross the Atlantic in 5 minutes. No bomb we've ever made could survive such an impact. So if we go for a head-on collision, the asteroid will wreck the nuke before it even has a chance to explode. Okay, easy. Let's explode the bomb before it touches the asteroid. Scientists have estimated the optimal distance, which for our 100-meter killer friend would be a few tens of meters above the surface. Launch, set the timer, and… the explosion has made a dramatic crater and nothing else. Unfortunately, in space there's no air to carry a shockwave, so most of the explosion's energy is lost. The rock will still hit us in 2 weeks, only a few kilometers to the left. Striking such a behemoth with a nuke is like hitting our cargo ship with a washing machine instead of potatoes. Better, but still useless. Okay, let's go the movie route. Land someone on the asteroid, drill a hole, and bury a nuke inside to avoid all of these problems. And indeed, this is possible in theory, albeit suicidal in practice. Landing on any space body is a nightmare. Even on fairly big Mars, whose surface we know almost perfectly, roughly 70% of our attempts have failed. So imagine the chances of landing a crew and a nuclear bomb on a small and extremely fast asteroid discovered just 2 weeks in advance. Even if we succeeded, drilling in microgravity is painfully slow since there's no downward pull to help you. So we'd need an agonizing amount of time that we don't have. So sadly, that's not the answer. We have to think less like Hollywood and more like a lumberjack. The smart way. If you want to split a log, you don't hit it with a rock. You use an axe, a dense and perfectly shaped tool designed to break things apart. And just in the same way, scientists have found a new tool to destroy asteroids: super dense, ultra-fast cosmic bullets. We won't even have to shoot them. Our cosmic bullets are called penetrators. A few meters long, slim and made of tungsten, a metal way denser and harder than rock. They work in an extremely simple way. You just put the penetrators in the way of the asteroid to float silently in space. From the perspective of the asteroid, you wouldn't see a few tiny bullets sitting still. You'd see them rushing at you at 70,000 kilometers an hour. It doesn't matter who stands still and who's fast. But this speed means that by far the longest part of this mission is to get to the asteroid in time. We can't destroy it too close to Earth because its fragments will slam into the atmosphere all at once with the power of thousands of nuclear bombs. Our atmosphere can absorb isolated chunks, but if thousands of them strike together, their shockwaves will add up and kill millions. So instead, we need to get it one day before impact, when the asteroid will be nearly 2 million kilometers away, more than 4 times further than the Moon. A vast distance, but doable. Our current rockets can cover this in about a week. We'll just send one penetrator about 2 meters long and weighing 2.5 tons. Once our rocket arrives, it puts the penetrator in place to cause maximum damage, and then we wait. A tiny speck of light appears in the vast distance, and then suddenly it's here, shooting at us faster than the speed of sound. We'll slow down time to see exactly what happens. The asteroid crashes into the penetrator so fast and with so much violence that the power of 120 metric tons of TNT is released into the asteroid. The rock vaporizes and the tungsten melts away, carving a wound that tunnels through the asteroid. The damage is too much, and with all of this energy looking for a place to go, the asteroid is blasted into thousands of pieces. The debris spreads out into a diffuse cloud. A day later, the fragments hit Earth, dispersed over hundreds of thousands of square kilometers and turning an apocalypse into a mostly harmless show of cosmic fireworks. So if we prepare and get everything ready, spotting a killer asteroid with 2 weeks' notice would be enough. But this is just a small asteroid. What if we face a cosmic mountain, a planet killer carrying the destructive power of tens of thousands of nuclear arsenals? The non-avian dinosaurs would tell you about it, but they're dead. What if it is a planet killer? Planet killers are objects so vast and powerful that they would end most life on Earth in a single strike. The most dangerous ones are comets from the outer fringes of the solar system, so distant and dark that tracking them is impossible. Comets are dirty ice balls the size of mountains, more fragile than pure rock, but also much faster and violent, traveling at around 140,000 kilometers per hour. In 2020, the comet Neowise, with the power of 6,000 times all the nuclear bombs on Earth, was discovered just 4 months before its closest approach to Earth. What if we find such a beast 6 months before it's going to crash into us? Do we have a chance of surviving this? Unfortunately, this would be extremely hard for a bunch of reasons. First of all, our planet's killer comet has so much more mass than a tiny killer asteroid that simply breaking it into millions of pieces would not help us that much. The chunks that hit Earth would still be massive and numerous enough to set the sky ablaze and kill most life on Earth. So we need to make most, if not all of its fragments completely miss Earth. But to do that, we need to destroy it much further away, as far away as Mars. And to destroy a mountain, we need way more penetrators. Hundreds of thousands. And this is, well, a huge problem. To travel this far and to transport this much payload, we need at least 24,000 super heavy rockets. As of today, humanity has 2, and they're not really finished yet. Even if all the industries in the world do nothing but switch to building rockets, we wouldn't finish in time. If we actually discovered a planet killer today, there's literally nothing we could do about it. Except maybe if we combine penetrators with a bit of Hollywood and our old friend the nuclear bomb, there is still a way. For this plan to work, we basically need to have all the parts ready beforehand. A rocket like NASA's SLS, the one planned to take astronauts to the Moon, loaded up with everything we need, ready to launch. As soon as the planet killer is spotted on its way to wipe us out, we launch a single rocket to meet it. For 5 long months, it travels through the nothingness of space as life on Earth nervously continues. Finally, it reaches its destination a bit beyond the orbit of Mars. Now, we deploy 5 massive penetrators in sequence, one perfectly lined up 2 kilometers after the other. The engineering challenge of aligning and timing this correctly is horrendous, and we only have one attempt. So, a few very brave astronauts go on this one-way trip to supervise the process with no way home. Nervous hours pass as all of humanity watches the skies and screams. And then the moment comes. The icy mountain of death appears in full, and then it's already here. Slow down time again. The comet smashes into the first penetrator at 140,000 kilometers an hour, unleashing the power of 2,000 tons of TNT. Ice, rock, and tungsten liquefy in an instant as the energy of the impact eats itself dozens of meters deep into the mountain. here's the second one, perfectly hitting the same spot, punching directly into the crater, smashing, melting, drilling. The third and fourth penetrators repeat the process again, now smashing a tunnel about 100 meters deep. But this time, this is just a scratch on the surface of the monster. The comet is not really damaged yet. And then comes the final penetrator and its toxic load. 300 megatons in nuclear warheads, 20,000 times more energy than the bomb that destroyed Hiroshima. It travels deep into the tunnel, and just before it hits the end, it explodes. This time, the nuke works. Instead of hitting nothing in the vacuum, the energy of the explosion smashes into rock and gravel and ice. On top of vaporizing it from the inside, there's so much shock and push and punch that a frozen world billions of years old dies from within, turning into a cloud of millions of fragments spreading in all directions. Humanity is saved. To make this happen in reality would take unprecedented planning and precision, and yet it's possible. Not in a century with sci-fi technology, just with the rockets, engineering and knowledge we already have today.